This is Module 1, Introduction to Programming, Lesson 4. Let's just have a quick recap of what we've done so far. So first of all, we have, there we go, we've done Lesson 1, which is Introduction to Programming, setting up Visual Studio, working with C# and data types and operators, so some simple adding. Then in Lesson 2, we did classes and constructors. In Lesson 3, we did create methods and passing values. And now we're doing Lesson 4 on, in more detail, access modifiers, static, read-only and constant added in there as well. So let's have a look at what we're working with so far. So, I've already got the project set up. This is a new project, added the same solution. And this program class, nothing in it yet, so it's totally blank. We're going to add a new class, and this time we're going to just do, I'll just put shapes in, that's a nice and simple one to use. So it's a shape class. Imagine with a shape class you can create rectangles and circles from this shape class. So, few things. First one we'll look at is access modifiers. So there are 3 different types. I'm going to just use numbers, just as arbitrary stuff for this shape thing for now. So let's do a public int. I'm just going to call them int a. Actually, I'll tell you what. A public, just so we can see what's going on. Public int b. Trying to print something off there, not going to do that. Private, and actually, what am I doing? That should be private. And protected int c, protected. Okay, so I'm going to create new instances of that class inside here. So let's quickly just do shape s equals new shape. Be really quick here, and then s dot. Notice I can only grab the public variable. I can set it as a number, or I could multiply it and add it by itself and do all the usual stuff. That's because it's public. So public means it can be read by other classes. So shape is a class. By setting this integer as public, it means that the program can read it. The same can be applied for methods as well. This one that is set as private can't be read. It can't be read, it can't be written, it can't be seen by other classes. I'll show you what happens if I type her in. It was be private. Private. And it says it is inaccessible due to its protection level. Yes, so that is inaccessible due to its protection level. The reason why is because that says private. So what is protected? Is that what I actually called it? Yeah, I did. So why can I not access protected? Same reason. It's inaccessible due to its protection level. But there's something I haven't covered, and I'm going to cover it a lot later on. After we've done some game stuff, we're going to look at how inheritance works later. But for now, I'll just quickly throw something together. This will be a rectangle. Rectangle. In programming, if you demonstrate inheritance, what you're doing is you're saying that everything that belongs to the shape class thing in this one belongs to the rectangle class. There we go, looks like that. So what we can put in here is I'm demonstrating protected. So if public can be read by any class, private can be read by no classes, and protected can only be read by classes in its family tree almost. So I can use a public, a public. Can I just type that in? I've got to put it in a constructor or a method or something. Just ignore this for now. I'm just trying to demonstrate something. A public. Can I do that? A public. There we go. A public equals what? 1. I can't do B private because it's inaccessible due to its protection level. But I can do C protected, and I can set that value. Okay. So that was very quickly looking at those 3, but there's more that I want to look at in more detail. I'm going to delete this rectangle class for now. And go back onto the shape class. I'll leave those in for now just for reference. What if the shape class had a variable that I don't ever want to change? If I never ever wanted to change it, you would use constant. So let's see how that might work. I'm going to create a public constant integer called pi. So maybe I was trying to work out the area of something. So I create this public constant integer called pi. Actually, well, technically pi won't be an integer. It would be more like a float or a double. And I'm getting an error here saying that const field requires a value to be provided. Okay, so how constant works is it'll always be that value. So if it'll always be a value, it has to always receive a value, otherwise it's pointless having it empty. I'm going to just type in 3.14f. You've got to use f because to say that it's a float. Okay, so I'm always saying that pi is 3.14f. I mean, yes, it's more of an exact number, but obviously not going to be putting that in. So how does that work? Let's have a look at it. Is public, so we should be able to read and write that. Let's have a look. S dot it's not coming up. S dot a public equals S dot pi. Can I do that? What does it say? Why can I not access that? Cannot be accessed with an instant reference. Qualify it with a name instead. Alright, so what's going on here is it's saying that you can't actually initialize or access this from an instance of a class. So you can't just grab pi from S. We can't just do that. That's because const is static. So I'm going to come back to that in just a second. We can use static to access something where we don't want to change the values. Sorry, I'll say that again. We use static where we might want to access or an attribute or run a method without initializing object based on a class. I'll demonstrate that. So if I type in public static and d static, so we're just going to give that a name just like that. I'll try typing in s dot. Right, that static thing isn't there. It actually looks more like this: shape dot d static, and there's that value there. So that d is now set as 10. Notice pi was there as well. I can also use pi. How does that compare against read-only? So a read-only value, so public read-only int e read-only, that'll do. It can be empty on time of initialization. When you create it, can be empty, or it could be a value. But once the value is set, it can't be written over, it can only be read. And you can use that in that instance. You can initialize, you can read it from the object of the class. Why would we use static though? So I know a lot of my students can't or struggle with why I would use static over anything else. Let's say we wanted this shape class to work out area of a rectangle, but we could use it as a method, and we can just do it anytime without initializing instance of a class. So in fact, I'm just going to get rid of all of that, and I'm going to put a method together. Public, because we want it to be read by another class. Static, and it's going to work out the area of a rectangle, which will always be a whole number. So let's just put in int for a whole number. Area of rectangle. Last week we looked at passing values. Yeah, so this is a method. We're going to put those brackets in, and we'll put two values in: length, int width, and then close those off. And then we're just going to do length multiplied by width, and then multiplied by equals, and then return length, because that's going to be the taking that number, multiplying it by the width, should return that. So now if I type in console, console dot right line open brackets, and then we'll just do shape dot area of rectangle, which is the static method, open brackets, asks us to put a length and a width in, so the length will be 10 and the width will be 20, and then hit semicolon at the end. Console dot read line. Look, notice that these are actually static methods as well. Run. We don't have to create a new instance of the console at all. We can just access console.writeLine straight from the console class, which demonstrates that it is actually a static method. So it's coming up just now, and it should output 200. There we go. So it's output at 200. So I haven't had to initialize anything. I've just run this area rectangle method that I created, and it's worked that out. Okay. So let's recap what we've done. We have covered static, covered read-only, and we've covered constant, and we've covered access modifiers. That's as far as we need to go, and that should bring it to the end of module 1, introduction to programming. That is done, out of the way. If you feel uncomfortable going ahead, please give this another go, but you're going to see all of this in action next time.